Welcome class 6. Today we will start in physics, a new chapter, light. Now before we go on to this, we should know that what is energy, because light is a form of energy, so we should know what energy is. Now energy, before that we need to know what work is. Okay, work is done when an object moves from one place to another. Okay, when I move from this place to this place, I have done work. I made my body to do work. But to do this work, I need energy. And where do I get that energy from? I eat food, no? From that food I get energy. But there are so many other non-living things also, which also move from one place to another. For example, light. Light is a non-living thing, right? But it still moves from one place to another. Imagine sun so far away from our planet Earth, but light from the sun comes to our planet Earth, isn't it? So that light from sun has come to our planet Earth. It has moved from one place to another. That means it is doing some work. Light is doing some work. And since light is doing some work, it needs energy. So light is a form of energy. So what is this energy? Energy is the capacity of the object to do work. Unless I have that energy, I can't move from one place to another or from here to here. I need energy. Any object which moves from one place to another needs energy. So light also needs energy. Okay? So energy is there in light also. So light is a form of energy. Light is a form of energy because particles of light can move from one place to another. So light also is a form of energy. Okay, now coming to the book. Now in your book it says rectilinear propagation of light. This is the first heading in your book, page number 49. Page number 49, if you turn to your book, there the first topic regarding light is rectilinear propagation. Rectilinear means straight line. Okay. Linear means line. Rectilinear means straight line. Curvilinear means curved line. We will learn these terms later on also. But as of now, rectilinear means straight line. That means light travels in a straight line. Any diagram of the sun, from where the light is coming out, you might have seen the rays of light are given this way. These are the lines. These lines represent light. Okay? And light travels in straight line. So, light traveling in straight line is called rectilinear propagation of light. Keep this in mind. Light always travels in a straight line path. Okay, now we are studying rectilinear propagation of light, right? So, in regards to that, we have to know what a ray of light is. A ray of light is a straight line with an arrowhead. Now, this straight line, we know that light travels in straight line, right? So, this straight line denotes the path of light, and the arrow tells us from where to where the light is traveling. Okay, so a ray of light is a straight line with an arrowhead representing the direction or the path of light. Light travels in a straight line path, and that straight line path is denoted by drawing a a straight line or many straight lines together. Okay, so we can have so many types of ray of light. Okay, parallel ray of light. In parallel ray of light, we will have so many rays of light parallel to each other like this. See, I have drawn here so many rays of light. Arrow should be drawn, arrow indicates the direction. All these are parallel to each other, so they are called parallel rays of light. Okay. Now we say that the sun emits parallel rays of light. Remember, any object which is very very far away from us and the light coming from us, they come parallel like this. Okay, they come in parallel rays of light. Okay. Now there can be converging and diverging rays of light also. Converging rays, rays of light. Now what's converging? It's like this. See, from so many different directions, light is coming to one point. Okay, they are coming and meeting at one point. Such kind of rays are known as converging. Converging means to come from different directions and meet in one point. Like that, we have diverging rays of light. Okay, diverging rays of light. This is opposite of converging rays of light. Here, from one point, let me draw this, then I will explain. See, from one point, light is distributed in different directions. Okay, light spreads from one point in different directions. They are not parallel to each other, mind you. Here also, they are not parallel to each other. They are coming from different directions. In this case, converging and coming and meeting at one point. And whereas here it is opposite of converging. In diverging, what happens? From one point, the light is scattered in different directions. So you can give example over here. Light bulb. Okay, a light bulb. This is how we denote light bulb in physics. While we draw. So from a light bulb, when light is on, light goes in different directions from one point. That is the point from where the bulb is. And for this one, the example you can give is different persons owning their torch lights and focusing in one direction. So light rays from different directions are focused in one direction. So these are the different rays of light and types of rays of light. So overall, what I want to prove is that light travels in a straight line path. Alright. You can now look at this diagram over here. Similar diagram is given in your book also on page 49. Now this diagram proves that light travels in a straight line. On this point we have been studying the same topic, light travels in a straight line. Now see the top one. Here is a person who is watching this burning candle. Now this burning candle emits light in different directions. You see, I have drawn here different rays of light representing how light travels from a burning candle in different directions. So this also is a diverging rays of light. Earlier what example I have given you. This is also an example of diverging. From one point, rays of light are distributed in different directions. Okay, now one such ray enters the pipe, goes straight, and this person is able to see this burning candle through this straight pipe. Because light travels in a straight line, so there is no problem viewing this burning candle by a straight pipe. Now what will happen if the person changes the pipe and instead of straight, now a bent pipe is taken. See, here it is bent a little. Now what will happen? Will the rays of light go like this? Will it go straight, bend like this and again come this way? No. Light doesn't travel that way. So if there is a bend over here, light will no longer pass through this and the person will not be able to see the candle through this bent pipe. Okay? The pipe needs to be straight because light travels in a straight line path. Light doesn't travel in a bent path like how the pipe is bent over here. Light doesn't bend that way. Light goes in the straight path only. So what will happen? Light will come here. It may enter here. Okay? Bounce back again. From here it came and from here only it will be. It cannot bend and go. Also in your book, on same page, page number 49, you will see this diagram over here. See, on top there are 3 cards and on the left side of these 3 cards there is a candle burning and on the right side there is a person, only the eye is given over there. Now these 3 cards, when they are placed in one straight path, you can see all the 3 cards in the middle they have a hole. Now this hole, if it is arranged in a straight line, then the person who is on the right side can see this candle on the left side, which is in opposite direction towards the card, towards where he is located. From there, on the other side of these 3 cards, the candle is there and the person can see the burning candle. But now, see the diagram below. One of the cards is moved a bit. See the third number of card or the first card from the person is moved little bit. Now all the 3 holes are not in the same line. See, card A and card B, they are in the same line, but C has moved. Card C has moved. Now the person will not be able to see the burning candle. So this is also another proof that light travels in a straight line path. Also here in this picture, not only in this picture, even in your house also, early in the morning when the sun rays come into your house from the ventilators or from the window, you might have seen the dust particles in the sun, and through these dust particles you will see that the rays of the sun come in straight line. Okay, in this forest, through the woods, through the trees, can you see rays of sun coming in between the gaps where the leaves are? From there also light of the sun is coming in straight line path. So all these prove that light travels in a straight line path.